Hello everyone, I am Mary Swarnalatha, working as Assistant Professor in the Department of Electronics and Communication Engineering. In today's lecture, we are going to discuss about the joint probability density function, properties of joint probability density function, and the marginal density functions. So, already we have seen the probability density function for a single random variable. So, how can you define a probability density function for a single random variable? For example, x is a random variable, then the density function for that random variable is represented by f(x) of x is equals to what? The differentiation of the distribution function. It means the relation between distribution function and density function is what? The density function is obtained by differentiating the distribution function. So this is for what? A single random variable. Now, if we want the density function for more than one random variable, then we call it as what? Joint probability density function. Therefore, if x and y are two random variables, and if you want to calculate the joint probability density function of those two random variables x and y, then it is represented by fxy of x comma y is equals to dou square fxy of x comma y by dou x into dou y. What does it mean? For single random variable, it is a differentiation of first derivative of the distribution function. And for two random variables, the joint density function nothing but what? It is a second derivative. This is of order 1 and is of order 2. So for two random variables x and y, the joint density function is defined as the second derivative of the joint distribution function of those two random variables x and y. And in a similar manner, we can write down for three random variables. For example, x, y, z are three random variables. Then the joint density function for the three random variables is written as fxyz of x comma y comma z is equals to. If it is one random variable, it is a first order derivative. If it is for two random variables, it is a second order derivative. If you want for three random variables x, y, z, and it is a third order derivative of the joint distribution function fxyz of x comma y comma z by dou x into dou y into dou z. And similarly, you can write down the joint density function for n number of random variables also. The joint density function for n random variables is defined as the nth derivative of the joint distribution function of the n random variables. So like that, we can define the joint probability density function. And coming to the properties of the joint probability density function, the first property states that always, if you take any value of x and y, always the joint density function is a non-negative value. That is the first property. So the joint density function is always a non-negative value. And the second property states that the area under the density function is always is equals to 1. So this you can write as what? It is a condition of what? A proper joint density function. So this is nothing but area property. So if density function is a valid density function, then you can say that the area under the density function is equal to 1. And the third property states that if you want the distribution function of two random variables in terms of the density function. So previously, what is the density function definition we have seen? fxy of x comma y is equals to what? The second order derivative of the joint distribution function dou square fxy of x comma y by dou x into dou y. And so the density function is equals to what? Differentiation of the distribution function. Similarly, if you want the distribution function, then nothing but what? The integration of the density function. Since the joint density function for two random variables is a second order derivative of the distribution function, if you want the joint distribution function for two random variables, it is defined as the second double integration. Since it is here second order, here you have to take the double integration. So double integration of the joint density function over the limits minus infinity to x and minus infinity to y. And here x may be up to infinity and y may be up to infinity. And the fourth property states that the marginal distribution function of the random variable x. So the marginal distribution function of the random variable x is obtained by keeping y equals to infinity. There is a third property. And the fourth property states that the marginal distribution function of the random variable y is obtained by keeping x as infinity. And the sixth property gives the sixth and seventh properties. Both gives the marginal density functions of the random variables x and y. Fourth property and the fifth property gives what? The marginal distribution functions of the random variables x and y. And the sixth and seventh property states the marginal density functions. So marginal PDFs, probability density functions. So the marginal density functions can be obtained by keeping any one of the variable to infinity. If you want the marginal density function of x, you have to keep y as infinity. If you want the marginal density function of the random variable y, you have to keep x as infinity and you have to integrate with respect to x only. And the eighth property states that always the joint density function is continuous for all the values of x and y except some final value. For example, if x and y are discrete, then it is not continuous. If x and y are continuous random variables, the joint density function is also a continuous function. And the ninth property states that if you want to calculate the joint probability such that the random variable x takes from x1 to x2 and the random variable y takes to from y1 to y2. So this can be obtained by double integrating the joint density function of the random variables x and y within the limits of x1 to x2 and y1 to y2. And the 10th property states that if two random variables x and y are statistically independent, then the joint density function of those two random variables is equal to the product of the marginal density functions. So we'll prove one by one property. So the second property states that, what is the first property states that? The first property states that the joint density function is always a non-negative value. What is the second property here? The area under the joint density function is equal to 1. So let us prove how do you get this property. So what is the property here? The area under the joint density function is equals to 1. So how can you obtain the area? The area can be obtained by integrating that function within the limits minus infinity to infinity. Since you are having two random variables, you have to integrate both the variables x and y within the limits minus infinity and infinity. So let us prove this. You have to prove that this is equal to 1. So let us prove this. So integration minus infinity infinity and integration minus infinity fxy of x comma y. What is fxy of x comma y? Nothing but the second order distribution function. The joint density function is defined as what? The second order distribution function. So into what? Dx into dy. So that equals to, so integration. So here this is a differentiation with respect to x and y, and this is the integration with respect to x and y. Therefore both will be get cancelled. Then we can obtain as what? fxy of x comma y and the limits of x from minus infinity and the limits of y are from minus infinity to infinity. So that equals to fxy of, so what is the upper limit here? X is infinity. So first we substitute the x limits. Then what can you obtain here? Infinity comma y minus fxy of minus infinity comma y. So, and what are the limits of y here? Minus infinity and infinity. Now, what is fxy of infinity comma y? That is nothing but what? fxy of, so we have seen in the previous lecture the properties of the joint distribution function. So from the properties of the joint distribution function, you can say that by keeping any one of the variable to infinity, you are going to get the marginal distribution functions. For example, if you are keeping x as infinity and y as it is, then you will get the marginal distribution function of the random variable y. And if you keep x as y as infinity in the joint distribution function, then you are going to get what? The marginal distribution function of the random variable x. So this can be obtained from properties of joint distribution function. Now, so what is fxy of infinity comma y? So by keeping x as infinity, you are getting the marginal distribution function of y. That is nothing but f by of y minus, and from the properties of the joint distribution function itself, what is fxy of minus infinity comma y? In the joint distribution function, if you keep any one of the variable, either x as minus infinity or y as minus infinity, the value is what? 0. Therefore, this is 0 and the limits are from minus infinity to infinity. That implies fy of infinity minus fy of minus infinity. What is fy of infinity? From the properties of the distribution function, that value equals to 1 and fy of minus infinity equals to 0. That equals to what? 1. So, therefore, we can say that the area under the joint density function is equal to 1. And what is the next property? Third property is what? The joint distribution function can be obtained as the integration of the joint density function over the limits xn from minus infinity to x and minus infinity to y. So let us prove this property. So what is the third property here? The joint distribution function can be obtained by integrating the joint density function over the limits minus infinity to x and minus infinity to y. So here in place of x and y, I can replace by some variable, dummy variable u comma v. So fxy of u comma v into du into dt. Now we'll take the RHS first. So what is here? Integration minus infinity to y and integration minus infinity to x. So what is fxy of u comma v? So what is a joint density function? Fxy of x comma y is equals to what? The second order derivative of the joint distribution function. Now in place of my small x and y, I am having here u and v. Then how can you write down here? Dou square fxy of u comma v by, in place of x I have here u and in place of y here I have v. Therefore dou u into dou v du into dv. And the differentiation and integration will get cancelled. Then what can I obtain here? Fxy of u comma v and the limits of u from minus infinity to x and the limits of y, not in place of y I have here v. Therefore v are from minus infinity to y. So that equals to what? Fxy of, what is the limit, upper limit of u here? X. So x comma v minus the lower limit of u is what? Minus infinity. So minus infinity comma y, whereas the v limits are from minus infinity to y. So it goes to fxy of x comma v, this is u, sorry, the x comma v minus, what is fxy of minus infinity comma v? So in the joint distribution function, if you keep any one of the variable as minus infinity, then that value is 0 from the properties of the joint distribution function, which already we have discussed in the previous lecture. So therefore v limits from minus infinity to y. Now substitute the v limits. Therefore what can you obtain here? Fxy of x comma, what is upper limit here? Y. In place of you substitute y minus the lower limit is what? X comma, in place of you substitute the lower limit minus infinity. That equals to what? Fxy of x comma y minus. So I already told you that in the joint distribution function, if you keep any one of the variable as minus infinity, that value equals to 0. Therefore that equals to 0. So that equals to what? Fxy of x comma y. This is nothing but your LHS. Therefore, what can you say that? The joint distribution function of two random variables x and y is obtained by integrating the joint density function within the limits minus infinity to x and the limits from minus infinity to y. And the fourth property states that what? The marginal distribution function of the random variable x can be obtained by keeping one of the variable to infinity. So here you have to give y is equals to, sorry, here. So what is fxy of u comma fxy of x comma y equals to integration minus infinity to y minus infinity x fxy of u comma v du into dv. Now what I want here, I want the marginal distribution function of the random variable x. If you want the marginal distribution function of the random variable x, you have to keep y as infinity in the joint distribution function. Now keep here y as infinity. Therefore, what can you obtain here? Integration minus infinity and integration minus infinity to x fxy of u comma v fxy of u comma v into du into dv. Now let us take the RHS side. So integration minus infinity integration minus infinity x. So what is the joint density function? That is nothing but what? The differentiation of the joint distribution function. Since there is two random variables, you have to take the second order. So fxy of x comma y. So in place of x and y here, I am taking u comma v. Therefore u and v. So dou u into dou v du into dv. So since the differentiation will get cancelled, then what can you obtain here? Integration. So those are cancelled here. Then what can you obtain here? fxy of u comma v and the limits of u from minus infinity x and the limits of v from minus infinity to v infinity. Therefore, just substitute the upper and lower limit. So first in place of u, I'll substitute. What is the upper limit here? X. So in place of u, just substitute x here. X comma v minus fxy of, in place of u, substitute the lower limit as minus infinity. So minus infinity comma y. Whereas the limits of y from v is from minus infinity to infinity. Therefore, what can you obtain here? fxy of x comma v minus, here the joint distribution function, if you keep any one of the variable as in minus infinity, that value equals to 0. Therefore, here it is 0 and the limits of v is from minus infinity to infinity. Therefore, what can you obtain here? fxy of x comma, in place of v, what is the upper limit here? Infinity. So fxy of x comma infinity minus fxy of x comma, in place of v, how to substitute as what? Minus infinity. That equals to what? What is fxy of x comma infinity? That is nothing but what? In the joint distribution function, if you keep any one of the variable to infinity, then you get the marginal distribution function. Therefore, if you keep y as infinity, you are getting the marginal distribution function of the random variable x. And here, in the joint distribution function, if you keep any one of the variable to minus infinity, that value equals to 0. Therefore, that equals to what? fx of x. That is nothing but your LHS. So, therefore, the marginal distribution function of the random variable x can be obtained by integrating the density function over the limits minus infinity to x and from minus infinity to infinity. In the similar manner, it can derive the equation for the marginal distribution function of the random variable y. Now, if you want the marginal distribution function of the random variable y, you have to keep which variable as infinity? You have to keep x as infinity. Because what is fxy of x comma infinity, fxy of infinity comma x? Nothing but what? Fy of y. It means you have to keep which as infinity? X as infinity. If you keep x as infinity, then you are getting the marginal distribution function of y. If you keep y as infinity, then you are getting the marginal distribution function of x. In which function? In the marginal distribution function. Therefore, if you want the marginal distribution function of the random variable y, which variable you have to keep as infinity? X as infinity. Therefore, here we keep x as infinity. And the next limits are from minus infinity to y. fxy of u comma v du into dv. So, in the similar manner, you can prove the marginal distribution function of the random variable y. That equals to integration minus infinity to y and integration minus infinity. And what is the joint density function? Nothing but what? The second order derivative of the marginal distribution function of the random variable x and y. So, by dou u into dou v into what? Du into dv. So, Since the integration with respect to u and v and integration differentiation is also u and v, both will be get cancelled. Then you'll get fxy of u comma v, and the limits of u of from minus infinity and v limits of v from minus infinity to y. If you substitute, you'll get as what? Fy of y. And the sixth property states that the marginal density functions of the random variables x and y. Okay. So what is the marginal density function of x? It is given by what? Fx of x is equals to integration minus infinity fxy of x comma y dy, because this is y. If you want the marginal density function of the random variable x, you have to integrate the joint density function with respect to y. And similarly, if you want the marginal density function of y, then you have to integrate the joint density function with respect to x over the limits minus infinity to infinity. Now we'll take the RHS side. So integration minus infinity, and you can write down the marginal density. So joint density function nothing but what? It is a differentiation of what? The joint density, so distribution function. Since it is a second order, two random variables, so take the second order derivative. So into what here? dy. So therefore, the differentiation here with respect to y and integration with respect to y. Then what can get in here? Dou fxy of x comma y by dou x, and the limits of y from minus infinity to infinity. So that equals to what here? Dou fxy of x comma, what is here? Upper limit is infinity. In place of which variable you have to do it? Y, because the integration with respect to y. Therefore, x comma infinity by dou x minus dou fxy of, what is lower limit of y here? Minus infinity. Therefore, x comma minus infinity by dou x. That equals to what? Dou, what is fxy of x comma infinity? I already told you that in a joint distribution function, if you keep any one of the variable to infinity, if you keep y as infinity, then you get the marginal distribution function of the random variable x by dou x minus in the joint distribution function, if any one of the variable value is minus infinity, you will get a 0. So here 0. And what is the differentiation of the distribution function? That gives what? The density function. Therefore, this is nothing but what? LHS. Therefore, the marginal density function of the random variable x can be obtained by integrating the joint density function with respect to y over the limits minus infinity to infinity. And the seventh property gives a marginal density function of the random variable y. Now, if you want the marginal density function of the random variable y, what you have to do? You have to integrate the joint density function of x and y with respect to which variable of y, if you want, means you have to integrate with respect to x in the limits minus infinity to infinity. And in the similar manner, you can prove the marginal density function of y as. So how can you prove here? Integration minus infinity. The joint density function nothing but what? The second order derivative of the distribution function by what? Dou x into dou y into here dx. And here the integration with respect to x and differential with respect to x, both will get cancelled. Then you get here dou fxy of x comma y by dou y, and the limits of x from minus infinity, and if you substitute in the, you'll get in the, as in the previous one, you'll get here fy of y. And the ninth property states that what? If you want the joint probability of any event such that the random variable x takes from x1 to x2 and the random variable y takes from y1 to y2. So this can be obtained what? By integrating the joint density function of the two random variables with respect to x and y with the limits of x1 to x2 and the limits of y from y1 to y2. Now let us prove this property. First you take the RHS side here. So integration y1 to y2 and integration x1 to x2 and the joint density function nothing but what? the second order derivative of the distribution function. Therefore, dou x into dou y into what? Dx into dy. So, integration with respect to x and y and the differential with respect to x and y. Both will get cancelled. You can write down here as fxy of x comma y, and the limits of x are from x1 to x2 and the limits of y from y1 to y2. That equals to what? Substitute the first x limits. So, the upper limit of x is x2. So, x2 comma y minus fxy of, and the lower limit of x is what? X1. So, x1 comma y. And what are the limits of y here from y1 to y2? Now, we substitute the y limits, then what can you obtain here? fxy of x2 comma, what is upper limit here? y2. So, fxy of x2 comma y2 minus fxy of x1 comma y2 minus of, what is the lower limit here? In place of y, y1 is the lower limit. Then you substitute here. So, fxy of x2 comma y1 minus fxy of x1 comma y1. Now, we have seen the properties of joint distribution function. There we have seen the probability of the random variables x takes from x1 to x2 and y takes from y1 to y2 is equals to what? Nothing but what? fxy of x2 comma y2 minus fxy of x1 comma y2 minus fxy of x2 comma y1 plus fxy of x1 comma y1. So, it's nothing but from this what I done here. This is nothing but what? P of x1 less than x less than equals to x2 comma y1 less than y less than equals to y2. So, where can you obtain this equation? So, this equation is obtained from the properties of the joint distribution function which are discussed in the previous lecture. So, like that, you can calculate the joint probability of the event such that x takes from x1 to x2 and y takes from y1 to y2 by integrating the joint density function over the limits x1 to x2 and limits of y from y1 to y2. So, next we will see the joint density function for discrete random variables. So, we have seen for discrete random variables, if you take a single random variable x, let us say only one random variable, then how can you write down the density function of that random variable? Fx of x is equals to what? Sigma m equals to 1 to m p of xm into del of x minus xm. So, this is for a single random variable. For example, if y is a random variable, then what is the density function for discrete random? What type of random variable here? They are discrete random variables which are take the only discrete values. So, sigma n equals 1 to n p of yn comma del of y minus yn. And similarly, if you want the joint density function for two random variables x and y, and those two random variables x and y are discrete random variables, then how can I write down here? Sigma n equals 1 to n, sigma m equals 1 to m, p of xn comma ym into del of x minus xn into del of y minus ym. Here, what is del of x minus xn? So, it's nothing but the delayed unit impulse function. That is nothing but it is 1 when x equals to xn and 0 when x is not equals to xn. And similarly, what is del of y minus ym? That equals to what? This is 1 when y equals to ym and 0 when y is not equals to ym. Like that, you can write down the joint density function for discrete random variables. Next one is, we'll see one problem in that. If the probability density function is given by fxy of x comma y is equals to 6 by 5 into x square plus y square for x is from 0 to 1 and y is from 0 to 1 and equals to 0 otherwise. What is the first problem you have to calculate? CDF of x and y. That is nothing but CDF is nothing but cumulative probability distribution function. Simply you can call this what? Distribution function. Okay, and second one is what? The probability such that x takes from 1 by 4 to 3 by 4 and y takes from 1 by 4 to 3 by 4. And the third problem is obtain the marginal density function of x and y. Nothing but you have to calculate fx of x and fy of y After that, you have to calculate the probability of the random variable y takes from 1 by 4 to 3 by 4. What is the first one you have to calculate? You have to calculate the series of x and y. There is nothing but joint series of x and y. How can you obtain this one? So this can be obtained from the properties of the distribution function. See here, they have given the density function, you have to calculate the joint series. It means you have to use the third property. Okay, and if you want the marginal density functions, you have to use the sixth property and seventh property. And then let us calculate. This is the first problem here. The first one is you have to calculate what? Series of x and y. Okay, so we'll solve this problem. So what is a joint distribution function? From the property 3 of 4. The distribution function integration minus infinity to y, integration minus infinity to x, fxy of u comma v du into dv. Rs here can take x comma y also, there is no problem. Okay, then integration minus infinity to y. Now, what are the lower limits of x and y? You have to take 0 and 0. Therefore, here the lower limits you have to keep here what? 0 and 0. What about the y and x? Here y may be any value from 0 to 1 and x may be any value from 0 to 1. So, into what? fxy of u comma v. What is fxy of x comma y? They have given 6 by 5 into x square plus y square. Then what is fxy of u comma v? Just replace x by u and y by v. Then what can you obtain here? 6 by 5 u comma v equals to what? 6 by 5 into u square plus v square. So 6 by 5 into u square plus v square. So 6 by 5 into u square plus v square into what? Du into dv. That equals to what? Integration 0 to y. 6 by 5 is constant and bring it outside. Then u square, integration of u square with respect to u is what? U cube by 3. Plus integration of v square with respect to u, v square is constant here, therefore v square into u. And the limits of u from 0 to x into what here? dv. That equals to what? 6 by 5 integration 0 to y. So what is the upper limit here? In place of u is x. Therefore x cube by 3 plus v square into x. The lower limit is 0. Therefore 0 by 3 and 0 into something like 0 here. And with respect to, so into what you have here? Into dv. And equals to 6 by 5. So now you have to do the integration with respect to what? V. So when you do the integration with respect to v, so this term will get constant. Therefore x cube by 3. Integration of 1 is with respect to v is what? V plus, and here x is constant and integration of v square is what? V cube by 3 and the limits of v from 0 to y. Therefore that can be obtained as what? 6 by 5 into, in place of v substitute as what? Y. Therefore x cube into y by 3 plus x into y cube by 3. That equals to what here? 6 by, if you take 3 common, then you will get here 15. So here 15, 6 by 15 into, so x cube y plus x y cube. That equals to what? 2 by 5 into, and you can take xy is also common. Then what can you obtain here? X square plus y square. Therefore, this is what? The distribution function of the random variables x and y. And what is the second problem here? You have to calculate the probability of x takes from 1 by 4 to 3 by 4 and y from 1 by 4 to 3 by 4. Therefore, what is the second problem you have to calculate? Probability such that x takes from 1 by 4 to 3 by 4 and y takes from 1 by 4 to 3 by 4. So this you have to use which property? You have to use a ninth property of joint PDF. What is property here? If you know the density function, how do you calculate the joint probability? By integrating the joint density function with the limits x1 to x2 and y1 to y2. So by using this property, we can solve this problem. So In place of x1, I am having 1 by 4, 3 by 4, and in place of y1 is also 1 by 4 and 3 by 4. Substitute x1, y1 and x2, y2 values here. And what is fxy of x comma y? 6 by 5 into x square plus y square into dx into dy. 6 by 5 is constant, and integration of 1 by 4 to 3 by 4. So first I'll do the integration with respect to x. Therefore, what I get here? X cube by 3 plus y square into x. And what are the limits of x here? X is equals to from where to where? 1 by 4 to 3 by 4 into what you have here? Dy. Then equals to what? 6 by 5 integration 1 by 4 to 3 by 4. So in place of x substitute as 3 by 4. So here 3 by 4 whole cube by 3 plus y square into 3 by 4. So this is the upper limit minus what is the lower limit here? 1 by 4. So 1 by 4 whole cube by 3 minus here what you get here in place of y square equals in place of x, the upper limit is what? 1 by 4 into what here? Dy. After that you do the integration with respect to y. So you can get this value, or else you can do like this also. So what is fxy of x comma y you got? You got fxy of x comma y is what? Previously what you got here? 2xy by 5. So and then similarly with respect to y you have to integrate. And then you have to integrate the value, or else you can do this like this also. So what do you want here? fxy of x comma y is 2xy by 5 2xy by 5 into x square plus y square. So what is the definition of fxy of x comma y? That is nothing but what? P of x less than equals to x comma y less than equals to y. Okay. Then here it means what? P of x less than equals to x is nothing but from where to where? Minus infinity to here. What is x value from? Minus infinity to x. What is y value here? Minus infinity to y. So in place of this here you have here x1, in place of here x2, here you have y1, and here you have what? Y2. Okay. Then what can in place of x and y, what can you do? You can substitute fxy of. So what is the probability here? P of fxy of x2 comma y2 plus fxy of x1 comma y1 minus fxy of x1 comma y2 minus fxy of x2 comma y1. So using this property also you can substitute. This is from what? From property of joint distribution function. So you can use this property, or else you can use the distribution function property. Now in place of x2, what do you have here? x1 equals to what? 1 by 4, x2 equals to 3 by 4. What is y1 equals to 1 by 4 and y2 equals to 3 by 4. You just substitute here. So then what can you obtain here? 2 into, in place of here x and y, what you have to substitute? You have to substitute x2 and y2. What is x2 value here? 3 by 4. What is y2 here? 3 by 4. So 2 into 3 by 4 into 3 by 4 into 5 into x square plus y square. So x2 square plus y2 square. Nothing but what here? 3 by 4 square plus 3 by 4 square. Plus fxy of x1 comma y1. In place of here, substitute here x1 and y1. Okay. So in place of x1, what do you have here? 1 by 4. And what is y1 here? 1 by 4. Therefore, what again here? 2 into 1 by 4 into 1 by 4 into, this is 2 by 5 into 2xy by 5 into x square plus y square. So 1 by 4 square plus 1 by 4 square minus fxy of x1 comma y1. In place of x as x1, in place of y as what? y2. And what is x1 here? 1 by 4 and y2 is what? 3 by 4. Then 2 by 5 into x1 is what? 1 by 4 and y2 is nothing but what? 3 by 4 into what do you have? x1 square plus y2 square. Sorry, x1 square plus y2 square. What is x1 here? 1 by 4. So 1 by square plus y2 is what here? 3 by 4 square minus 2 by 5 into here x2 comma y1. Nothing but in place of x as x2, in place of y as y1. And what is x2 here? 3 by 4 and y1 is what? 1 by 4. So here 3 by 4 into 1 by 4 into so x2 square plus y1 square. There is nothing but 3 by 4 square plus 1 by 4 square. So like that you will get the probability. And what is the third problem here? You have to calculate what? Marginal distribution functions of x and y. And then you have to calculate probability of y is from y1 to 1 by 4 to 3 by 4. So how can you obtain fx of x? That is nothing but by integrating the joint density function of the random variables x and y with respect to y in the limits minus to infinity. And what are the y limits in the given problem they are given? The limits of y they are given as 0 to 1. So therefore in place of minus infinity to infinity, substitute the y limits as 0 to 1. So in this what is here fxy of x is 6 by 5 x square plus y square into dy. So that equals to what here? 6 by 5 into integration of x square with respect to y is what? X square y. Integration of y square with respect to y is y cube by 3. And the limits of y is from 0 to 1. That equals to what? 6 by 5 into, we just substitute the upper and lower limit in place of y. Therefore what do you get here? X square plus 1 by 3. Substitute the lower limit. 0 into something here 0 and 0 cube by 0. 3 is nothing but 0. Therefore this is nothing but what? Fx of x. And similarly, what is Fi of y is equals to? You can write down directly here also. So what is Fi of y is equals to integration minus infinity fxy of x comma y. If you want the marginal density function of y, you have to integrate the joint density function with respect to what? X. And what are the limits of x in the given problem? 0 to 1. So 0 to 1. Therefore replace minus infinity and infinity by 0 to 1. And within the given limit, what is its joint density function? 6 by 5 into x square plus y square into dx. If you simplify, what can you obtain here? 6 by 5 into y cube plus 1 by 3. And next what you have to calculate? You have to calculate probability of y takes from 1 by 4 to 3 by 4. How can you obtain this one? From the properties of density function. So what is the property here? P of y1 less than y less than equals to y2 is equals to what? Integration y1 to y2 fy of y dy. Therefore here in place of y1 1 by 4, in place of y2 3 by 4 into fy of y. What is fy of y here? 6 by 5 into y cube plus 1 by 3. So y cube plus 1 by 3 into what here? dy. So the equals to 6 by 5 is constant. Integration of y cube is what? Y power 4 by 4 plus integration of 1 by 3 is what? 1 by 3 into y. What are the limits of y here? 1 by 4 to 3 by 4. That equals to what? 6 by 5 into substitute the upper limit. So 3 by 4 whole power 4 by 4 plus 1 by 3 into 3 by 4. This is upper limit minus the lower limit is what? 1 by 4 power 4 by 4 plus 1 by 3 into upper level. What is the lower limit here? 1 by 4. So 1 by 4. So like that you can calculate the probability of y takes from y1 to y2. So what is the given problem here? The given problem is what? They have given the joint density function. You have to calculate the joint distribution function. You have to calculate the joint probability. You have to calculate the marginal density functions. And then you have to calculate the probability of the random variable y takes from y1 to y2. So these problems can be solved by using the properties of the density function, the properties of the joint density function. Therefore, in today's lecture, we have discussed about the joint density function, properties of joint density function, and the marginal density functions. After that, we have solved one problem by using the properties of the joint density function. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.